This video file is recorded in Sabancı University during the recitations for the CS201 Introduction to Computing course, as it was given in the fall 2016 semester.
Alright, just before writing your code, and one of your friends is going to write the code, just let me give you the algorithm. We had some discussion here in meanwhile. The discussions where we wanted together to come up with an algorithm, how we are going to do this stuff. One of the proposals that we saw was the following. Just as it was the case in the previous example, we were going to take characters one by one, and if we see a new line, then if we see actually consecutive new lines, only one of them is going to be printed. Since, as you can see here, in the first line, it finishes with over a, and there's a new line. But we want that new line to be printed. However, the new line, which is in the third line, the new line in the fourth line, and we don't have anything else besides the new line, we don't want them to be printed. Meaning, if they're, and you know that in the ends of every line there's a new line. So when we get a character, if we got a new line and we get immediately after it another new line, meaning we have an empty line, we don't want to print the second, the third, the fourth, and so on. Okay? This was one of the ideas. Yes, it's working. However, the best thing that we can do here probably is the following, is to use the getLine function. The getLine function works in the following manner. It takes, as I already explained, it takes an input, which an Ifstream. The first parameter is the Ifstream. The second parameter is a string. And it takes all the line from the beginning up until the end. Returns true if we can get the line, returns false if we cannot get any line. But there's the interesting stuff here. The interesting thing here is that getLine function reads a line and from the input from the Ifstream, and the line that has been read is passed to the string without the new line. Okay? Meaning, if in this concrete example, if I take the first line, not probably, but for sure, I'm going to take everything with getLine except the new line character in the end. It's not going to be taken. Meaning that if we take into the consideration the input arrange.txt file, if I try to get something from an empty line, and the empty line has only a new line, and new line is not part of the getLine, so string in that case will be empty. Meaning that if I have a line which is empty, and empty lines have only a new line, but getLine doesn't take new lines as characters, meaning that if I try to take something from an empty line, the string, the parameter from the getLine function will be an empty string. So basically, the algorithm is we are getting new lines, and if the line that we already got is an empty line, then I'm not going to send it to the output. Otherwise, I'll send it to the output. This is it. It is similar, almost the same as the previous example. So you first, we read the input file, the output file, check whether there's a failure or not. If everything is okay, if we can open both of them, then we get lines one by one. If the line that I have, and pass them to the output. So I read the line from the input and print it to the output. If the line is empty, I'm not printing it. Meaning if there's only one new line, and getLine again doesn't take the new line, I'm not printing it. Okay, so your friend is going to write the code from the beginning, from scratch, and we can follow him up. Okay, you can start. You can, if you want, you can copy-paste the code from the previous example and write only the while loop. You are late, I'm sorry, so we were expecting you, but you didn't come, so your friend. I know you're happy about that. Okay. If you have questions, ask. It's very important to understand. I mean, you think, oh, it's very complicated. We have a lot of stuff to do, but it's so simple. Both for the Ifstream, both for the ofstream, you have like 4 or 5 functions you have to deal with: open, fail, operator input stream, output stream, and close, nothing else. Okay, of course, for the input file stream, you have the getLine function. It reads a line and puts the already read line to the string we are passing as a parameter. It is as simple as that. You cannot find the... So you can try maybe in my computer here to write your code. No problem. Close it, write it here. Okay, so we are going to make changes. I mean, the code that we saw in the first example is going to be the same. The difference is going to be in this else clause here, meaning that first it's like this. First we get the input file, then the name of the input file, the name of the output file. We try to open them here. If one of them fails, we will not proceed with the second one. So if we cannot open the input file, we will print the proper message, this is it. Then try to open the output file. If it fails, nothing is going to happen. However, if we open both of them, then this is the important part of the code. Let's see how your friend solved it. Okay, so your friend is getting lines using the getLine function. It takes an Ifstream, in our case it's input, and a string, str. But we haven't defined str, so yeah, we're going to declare it. Okay. So if we can read a new line, we are reading it, and let's see. If it is okay. If you write it like this, that means if str is equal to an empty space. But empty space and empty string is not the same, because empty space is a character also. That's why you have to delete this part. This is empty string. Yeah. And also if you want to check, this is the assignment operator. You should write two double equals, okay? So if the string is empty, meaning there is nothing in that line, we should do nothing. Okay. Just otherwise, so there is a good mistake here. What you're doing here, you take the string. If it's empty, it still is going to be outputted here, okay? But you don't want to do that. You want to output the line. You want to write the line in the output file, only if it's not empty. But you're writing it, and you're not asking about that. So wouldn't it be better if we delete this line here? Okay. So if the string is empty, we don't do anything. Otherwise, else, we write it to the output as it is. Okay. But, as you know, str doesn't take a new line. Okay, so we are reading a line, but the new line character, in the end, is not part of the str. So we should add it here. Arrows and line. Okay? This is it. You might write it in another way, which is better. If string is not empty, then output it. Otherwise, don't output it. Okay. You forgot to close the parenthesis here. The bracket. Okay, that's why we don't have this mistake anymore here. And in the end, don't forget to close the output file. Otherwise, it won't work. I mean, it's going to work, and it will be the output in your RAM memory, not in your hard disk. So output, close. You can close it at any place. You can close it before returning 0. Yeah, but after the while loop. Okay, because if you close it and try to write something after closing, you cannot write it. So yeah, this is it. Just run the code. No, you don't have to close it twice. You closed it once. What I was trying to say, okay, it's okay here, yeah. Because you closed it here after the while loop, it was okay, okay? But if you close it inside the while loop, then you're trying to read something that you have already closed, okay? So this is it. Run the program again. I think the name was input.txt. Okay, give the out name, let it be output, okay. txt. This is it. Now let's go to the solution folder here. Okay, so the input was already okay. And this is the output. Let me just take input arrange and put it here so we can test it. So I'm copying input arrange here. I'm deleting output. So your input will be, this was from another folder. In this folder, in the solution folder, this is the input arrange. So run the program. Let's see whether it's working properly. Okay, now check it in the solution folder. Yeah, okay. Show both of them. So the input. Yeah, so this is it. We have deleted the new lines. Thank you. You can have your seat. Any questions about this code? I mean, the most important part took like 5 or 6 lines. The other part is usually copy-pasted. I don't say to do that, but you can think about that, because you're checking whether you have opened or not, if there's any problem, does it exist or not, and so on. Now let's go with something new. An important topic in programming is called arrays. Do you know what is an array or not, and why we have to deal with them? Okay, let me tell you. Let's suppose that you're a programmer and a company, or let's say a university, is asking from you to write a program about the university, about students taking courses and keeping their grades in the program, okay? So what would you do? Let's say you should write a program for one student, and up until graduation, how many courses you should take approximately? I think 40 courses, if I'm not mistaken. So what would you do about that? One way of dealing with this stuff, the most inefficient way probably, is like this. So your grade is double, basically, a real number between 0 and 4. It might be 3.2, 3.7, 2.4, and so on. I'm not going to deal with letter grades, only with number grades. So you can do something like this. You declare a variable of type double. It can be float, even better if it's float. And the name of the variable is, let's say, variable is CS201. Here you put the grade of CS201. Another double. Let's say it's TLL. TLL what? 1? 101, I think? 4 or 1? 101, okay. Another course might be double Math 101. Is someone taking Math 101 this semester? Okay. Plus, yeah. So in the end, you will have like 40 variables. Is this an efficient way to do things? What do you think? What if you have to keep the variables of all of the students? What if there is a university with 100 courses? So this is not an efficient way to deal with this stuff. That's why we have something which is called array, a vector. Let me tell you what it is. You have seen it in the recitation, in the lectures. So what instead of doing something like this and having this is CS201, this is a double TLL, this is another double math 101, and so on, I want to have something like this. And I know that I put grades here, okay? And everything here is double, okay? It might be of any type, character, string, integer, whatever, okay? And I put the grades here. And I want to count them, so I start counting from index 0, then this is index 1, index 2, and so on. This is called a vector. And how do I declare a vector? The syntax of declaring a new vector is the following. Vector, then in brackets, in angle brackets, you write the type of the vector. Type can be double, integer, character, whatever. You give the name you want. And here, in brackets, you give the size, which is an integer. Integer size. For instance, I can say something like this. Vector type, so vector is always the same. Double grades, the name of the vector is called grades. And let's say that I should put 40 grades here. That's why I gave 40 as a parameter. So this is my vector, which is of type double, and its name is grades. I start from 0. I have 40 grades. And what's the number, the index of this guy here? 39, just as it was the case in the string class. Remember, you started counting characters of the string from 0 to size -1. Now, again, the name of all of this vector is called grades, and I put here grades. So here is the grade of, let's say, CS201. TLL, I might put it here. Math is here, and so on. And we know in advance. Let's say that we have grades here, like this is 3.2. This is 2.7. This is 3.7, and so on. This is 2.0. How can I access the grade of CS201? Let's say this one. If I know that the name of the vector is called grades, I can access it with this syntax. Grades, then you have those parentheses, medium parentheses, and you write 0, meaning that it's going to be how much? 3.2. So if you try to print it, see out. If you try to print it, the output will be 3.2. If you try to print the third one, meaning the one with index 2, it will be like this. Grades. Then you have 2. So what will be the output? 3.7. Okay? Now, how can I change? Of course, if I print grades 39, it will be 3.2.0. But if I print grades 50, grades 100, what is going to happen? What do you think? In this case, so grades 39, it is 2.0. And I don't have more than 39. But if I try to access the 50th element, what's going to happen? What do you think? You can make an analogy with the string class. If the string had, let's say, 40 characters, and you are trying to access the 41st or the 50th or the 100th character, what happened? Yeah, but can you access something that does not exist? No, it was a mistake, usually, compiler mistake, so the same applies here. And sometimes you don't know the size of the vector. That's why there is the vector base, by the way, is a class also. So you can see it as a class. I'm going to write it here, class, vector. And for the time being, I'm going to tell you only one member function of the vector, which is called size. And it returns an integer telling the size of the vector. In this case, what's the size of this vector here? It's 40. We started from 0, unfortunately for you, Jim. We started from 0. So it's 40, okay? Size returns this. And how can I access it? If I write something like this, grades, point, size. So I'm going to print 40 because we have 40 elements in this vector. Now, we are accessing the data. We saw how we can access the data. But how we can change the data? Very easy. If I write something like this, grades of 2 is equal to 4.0, meaning a student, usually this happens, is not satisfied with his grade, so he's retaking the course. Then this guy here, from 2.7, is going to be erased, and 4.0 is going to be assigned to this spot here. But remember, the index is always an integer, and it can be an expression. So you can write something like this, grades A plus B minus 1. But you should make sure that this expression A plus B minus 1 is an integer 1, and 2, it's in the range from 0 to 39. Okay? And you are going to access it. For instance, if A is 3 and B is minus 2, which index are we dealing with? So A is 3, A is 3, and B is minus 2. This will be index what? A, index 0, which is equivalent to grades 0, meaning it's 3.2. Now let's see an example using the vector class. I think the name of the example is random generator count. We are going to use again the random generator function, but we are not going to play the Russian roulette this time, fortunately for you. So this is it, and we are going to need the random generator class. So from your downloaded file, please copy paste those 3 files from your downloaded folder. Random generator header and CPP, the corresponding CPP, and random generator count. Copy it and send it to the solution folder here. And we are going to remove everything else. We don't need this stuff. We don't need prompt also. But even if it stays, it's not a mistake. So add existing item, the random generator, header and CPP, and the random generator count. Now I'm going to tell you what is this guy doing, and part of the codes are going to be written by us. Some small parts. Namely, things dealing with the vector class. You are going to write it on your own. So please follow me and try to do it, okay? Okay, we are busy with something else. Okay? So, what are we doing here is the following. The program asks from us to do the following thing. Please enter the minimum and maximum value range and the number of trials. Basically, I'm going to give a range. Let's say I'm going to give a range from 10 to 20. And I'm going to generate random numbers, like 5,000 random numbers. But they are in the range from 10 to 20. And I want to check out the percentage of those generated numbers. So how many of them were 10? Randomly, I got an output, an outcome of 10, an outcome of 11, and so on up until 20. You can give any range, any trial. But I'm going with 10. So the minimum range, I start from 10. I go up to 20, and I want to generate 5,000 random numbers in this range. So the output is going to be this one. I've generated them. And from those 5,000, 447 were 10s, 429 of them were 11s, and so on. Percentually, the corresponding percentage for each of them is given here. Okay? So you would expect, like, what's your expectation? From 10 to 20, how many numbers do we have? We have 11, okay? Because we don't start from 11 to 20, 11, 12, 13, 14, 15, 20. We start from 0, actually. From 10 to 20, we have 11 numbers. And we are generating 5,000 numbers. So if we generate them really randomly, approximately, you would expect that, on average, each of them will get each of those randomly generated number as an outcome. They will have one of these. I mean, on average, the outcome will be the same for all of them. Okay, so on average, you expect approximately equal numbers, equally generated numbers, randomly generated numbers for each of them. But since the 5,000 is not a huge number, it's not a big number, yeah, they're pretty much close to each other, but not really. If we increase this to, let's say, 50,000, 500,000, 1 million, and so on, then it will be better. But, okay, that code is, I mean, we should code this. I'm just showing to you the demo. So let's say I'm generating this much random numbers. It's too much. But as you can see, approximately the percentage is around 9% for all of them, 9.19%. Okay? This is the Chebyshevs theorem that we have been talking about. Now, let's go to the solution folder. I'm going to take it from the, okay, this is it, random generator count. Do you have it, can you check it in your, do you have the solution for this program, or we should, I think we should write it. That was our purpose, but maybe I've mistakenly sent you the solution. Let me check it. Yeah. So in the student's version, you don't have the solution. We should write it. So what are we doing? Initially, okay, I include the random generator class here, and also I forgot to tell you, in order to use vectors, you should include the vector class, vector library. Okay, it's written like this. It's not in parentheses, since the vector class is part of the compiler. Okay, that's why we write it in angle brackets. So what are we doing here is the following. I declare random generator number R. I declare those integer variables, trials, it was 5,000. Random value, the randomly generated number from R in that particular trial. Low and max is the range. In our case, it was 10 and 20 correspondingly. I prompt the user, please enter the minimum, maximum value, blah, 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 and I'm reading the low, max, and trials. You remember, I gave 10 for the low, 20 for the max, and 5,000 for the trials. Meaning I generate 5,000 random numbers. Now, what I'm going to do is the following, and you're going to help me with that. So I'm generating numbers from 10 to 20, let's say. From low to max. Let's generalize things. And I want to put them in a vector. Okay? Now, can you tell me how many elements do I have them? Yeah, you might say, okay, if you have from 10 to 20, then start, and I want, so I generate random numbers between 10 and 20, let's say. This is from 10 to 20, and we have more numbers. When an outcome is 10, I increment this. So initially everything is 0. Okay, so this is 10, this is 11. Initially everything is 0 up until 20. So I generate a random number. If the outcome is 11, let's say, I increment 11 and it's 1. Then if it's again 11, I make it 2. If it's 0, I make it 1. So I increment it. I generate random numbers and increment it, okay? But as you can see, I'm wasting this piece of memory from 0 to 9. Okay? What if the range started from 1000? Okay, so what I want to do is take this part here and shift it to the beginning. Okay? So yes, the index will be the same, but I know that index 0 is for 10. Index 1 is for number 11, 2 is for 12, and so on, up until index, let's say, size is for max. So, your job is the following. As you remember, when we declare a vector, we first write the name, the type. I mean, we write vector, the type of the vector is going to be integer, the name of the vector, random counter, and the size. So, how many elements we should have in the vector? Remember, in that vector, again, our whole algorithm is the following. We should count the numbers from low to max. We generate a random number. Whenever it's generated, the corresponding index is incremented by 1. So, I'm giving an example again. If I generate 10, and I assume that 10 is in index 0, keeps the numbers, the tens that are generated. Initially, everything is 0, up until here. So when I generate a 10, this thing is incremented. When I generate 12, this is incremented. I generate 12 again, this is incremented, and so on. Okay? I generate 11, this is incremented by 1. I generate again 11, this is incremented by 2. Okay? But again, I start from index 0. So my question is the following. What is the size of the vector? Because initially we should give the size of that. Can you tell me? It's? Trials is the number of generated elements. But, I mean, if I might generate 1 million numbers, but the range is going to be from 10 to 20. So always I generate random numbers from 10 to 20, and I generate billions of numbers. And I want to keep the count for each of them. So I ask this question, between 10 and 20, how many elements are there? 11. Yeah, so exactly. So if this is not 10, so as an example, I said from 10 to 12 to 20, we have how many elements? 11, okay? That's why this is going to be 0, 1, 2. This is going to be 10, meaning we have 11 elements, so size is 10. But if I generalize it, if I start from low, so low might be 100, and I want to keep the numbers, the randomly generated numbers up until 1000, from 100 to 1000, let's say this is max. How many elements do I have from low to max? I have max minus low plus 1. From 10 to 20, 20 minus 10 is 10, plus 1, 11. So, let's write it together here. Max minus low plus 1. This is done. Okay, now I generate a for loop. This for loop basically generates the random numbers. I start from 0 up until trials. So let's say if trials is 5,000, I generate 5,000 random numbers. I generate the random number, and you remember the random integer function, which generates a random number between low and max, and it returns an integer between in this range, and I assign the returned integer to random value. Now, how am I going to use this stuff in order to increment the corresponding index? What do you think? Let's take it as an example. So let this guy be low is 10, and I have 11, 12, and so on. So 10 is 0, 11 is 1, 12 is 2. In the case when we are generating the numbers in the range 10, 20 including both of them. So if I know that I start from 10, what I'm doing? So index 0 is I put 10s in the index 0, 11s in the index 1, 12s in index 2, and so on. So random number minus low, exactly. This is it, okay? Because what I was doing, I shifted, so if I, instead of starting from 10 to 20, I shifted it from 10 to the beginning. For how many spots did I shift it? For 10, okay? 10, 9, 8, blah, 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 up to 0, okay? It's exactly 10 spots. I shifted it for 10 spots. That's why the index will be random value minus low. And I increment it by 1. It's not minus low plus 1. It's random value minus low. Because I shift everything for low spaces. Okay, that's why instead of 11, you see, I have 1. Instead of 12, I have 2. Why? Because low is 10. I shifted it for low spaces. So, I generate a number, and I incremented the corresponding index. Another number, I generate, let's say 5,000 or trials number of numbers, and I increment the corresponding index. In the end, I want to print the percentage. So what I'm doing, again, I start from 0 up until what? Now I'm printing the vector. How do I print the vector? The content of the vector. I mean, I start from 0 up until where? An idea? Max minus low. Exactly. Because max was, I should go from 0 to 10. Okay? Max was 20, 20 and low is 10, so 20 minus 10 is 10. So I go from 0 to 10. But since this is smaller, 10 will not be included. Max minus low plus 1. Okay? Smaller than that is 10. Okay? So max minus low plus 1. Now I print I minus low. Why do I do that? Do you remember the output? Let me tell you. Let me remind you about the output. So this is random generator count. I'm giving ranges from 10 to 20, and I'm generating, let's say, 10,000 numbers. Okay, this is what I'm printing. And I'm printing it right now. I minus low. Why? Because if I want to print 10, this is low, I increment it by 1. And I increment it by low because I started from 0. Has been randomly selected, random counter, this stuff here. I think we will have a better understanding of this algorithm if I explain it on the board. So I start from 0 up until the index I've been using, and I print, okay, for 0 I remember that 0 was actually 10, meaning plus low. When the I is going to become in the next iteration 1, I mean it's 11, that's why I incremented by low again. Because you remember, I shifted for low, and I have in mind that since I shifted everything for low numbers, what I want to put in the index I, in the ith index, actually is the number ith plus low. That's why I'm writing it like this. Did you understand this code or no? How many of you? Should I explain it again? No? If you think that I should do it, just tell me. Also, this part is important. Okay, I'm going just to explain the general stuff here. So this is what we have here. Again, I give low and max. And trials. Okay. User is asked to give some input to them. I gave 10, 20, and let's say 10,000 trials. Now, I declared another vector which is of integer type, which is called rand counter. So this is my vector, rand counter. And the size of the vector was max minus low plus 1. Basically, it's 11. So this is 0, 1, 2. This is 10, starting from 0 to 10. And I'm going to write something, meaning that in the 0th index I put 10, in the first index I put 11, in the 12th index I put 12, meaning I shifted everything for low spaces. Initially, everything is 0. I might complain to this code, since initially I should have explicitly written that everything is 0. But by default, when you declare a variable of integer type, its value is 0. But you should make sure that it's 0. So I'm going to change it a bit. Here, initially I say everything is 0. Since I start counting the occurrences of the random numbers. So I generate 10,000 random numbers between 10 and 20. So 20 is put in the 10th index. I keep the count of 20s in the 10th index. And let's say I do the first trial. 12, the outcome is 12. So I increment this one. Again, I do another trial, 10. So it's incremented by 1. Another trial, I have as an outcome 10. So I'll have 2 here. Another outcome is 12, and so on. Okay? So in the end, here I will keep the count of random numbers generated, and I would expect something like I have here like 978, for instance. I have here 1,039 occurrences of 11. I have like 1,010 occurrences of 12, and let's say exactly 1,001 occurrences of 20s. Now I want to print them, but how do I print them? The format of the output, you saw it. So this is the part that I want to emphasize more. This cout. With this loop, I start from 0, of course, and I go to max minus low plus 1. Instead of doing this max minus low plus 1, which makes sense, you remember there was the member function size. We can use it here. Size gives the size of the output of the vector. So we can use the size of the vector, which is rand counter point size. And it returns the size. So I start from 0 up until the end. In each iteration I increment it by 1. And then I print it in the following format. So let me declare another variable I here, which I will be using for iterating. And the output will be here. I'll show a couple of the first 2 lines maybe. I start from 0. I is 0. So I'm saying I plus low. And low is 10. So I'm printing 10. 0 plus 10 is 10. Has been randomly selected. Has been blah, blah, blah. And then I print, you see, rand counter of I, meaning I print the index of the value of the index of 0. So 10 has been generated 978 times. Then I'm continue printing here. Okay. Which in percentage is the following. I know that I have, let's say, 10,000 trials. So I divide the occurrences of tens with the overall number of trials. And of course, I convert it to double. I'm going to get a number which is smaller than 1. Okay, since 1 means 100%. If I want to give that output in terms of percentage, I'm multiplying by 100. So 100 multiplied by this stuff. Let's say 978, when divided by 10,000, it gives something like 9.78, I think, yeah. When it gives something like 0.097. When I multiply it by 100, it's 9.7%, okay. Then I increment I becomes 1. And I enter the loop again. I see out. I print the I minus low. 1 minus low is 11. So 11 has been generated, has been randomly selected. I print the value of the index I of the rand counter vector. So this is the rand counter vector. Index I is 1. Rand counter of 1 is 1039 times with probability. Then I'm printing. I'm dividing 1039 with 10,000, which is, I think, 0.01 something. But I'm converting it to double. When I'm multiplying it by double, because if I don't convert it to double, I'll have 0 as an output always. If I convert it to double, the output of all this stuff will be, first I convert this to double, meaning that 1039 would be 1039.0. So when I divide it by trials, I will not have 0. Because if I didn't convert it to double, 1039 divided by 10,000 is going to be 0. Okay, so I'm multiplying by 100, it's again 0. So after dividing 1039 with 10,000, I have 0.10 multiplied by 100. It's 10.39%, and so on. Okay. This was an example of the vector class. Now, honestly, how many of you didn't understand the question? Raise your hand. You? Okay, if you have questions, ask me. Otherwise, we can continue with another example. Let's go with the letters. Do you want to have a pause or not? A break? Yes or no? Okay, 5 minutes, and we will be back with only one example. One more is left.